Okay, so let me do a few more fixes here. You can see I disconnected the delta time in our Interpolate, and instead I just simply used a simple add node to give in a value. We could also like put one in with a variable, but I don't really want to. I just gave in a relatively low value here, and then I clamped the whole thing between 0 and 1, because we should not get higher than 1 anyway. We're interpolating between the previous and the target. If we go to our animation blueprint, you can see we can, in theory, this interpolate is technically not wrong, though it might give a little bit of a problem, I would say. I would recommend you to turning this higher, let's say like 24 or something. We always have to test in between. This is going to give us a little bit of a jitter, which is fine though. And I'm actually going to my robot arm blueprint here. I'm actually going to lower this even a little bit more. Let's say like a 2 or something. I want to print this out. So the tick itself, I want to just simply print, just so I can see how fast it actually ticks. And we can also over here turn on show FPS, just so we get a feeling of how fast it's actually ticking. It's actually not too fast ticking. Yeah, it's not like literally every frame. We have a little bit of interpolation in there, so I think something like this is fine, and it's much smoother actually. You can see if it would tick each frame, this would be much faster. Next, we're currently taking the position of the character itself, but I want to not take the position. I want to get socket location from the mesh. With that, we can target a specific bone, and I'm going to use the head bone. I think it's written small. Also, we don't really need a transform here. I'm going to stick with a transform right now, but wouldn't matter, I guess. And with that, it should aim at the head. Let's see. There we go. Right. There is a little bit of a wobble in there. So the problem currently is when we are like walking in here, right? The thing can't go inside. So we kind of, what I imagine is it kind of wants to point over the head and then down to the head. So in our control rig, the easiest solution for that is just simply here in the first target, we're going to subtract something. And we're going to subtract on, actually add on Z, let's say like a 50 or something. Let's plug this in here and plug rotation in. Let's see. And now it's kind of pointing over the head, right? Though you can see if we go over here, the target is essentially over here. We can see this if we turn on the debug here. We're not going to directly see the character, but we can see it's kind of still pointing at the thing, and the thing is over the head. So what I want is in the two aims we have here, in the target one, I want to subtract the 50 from the Z again. And with that, hopefully, okay, interesting. Maybe it also wants, oh, we're adding it, sorry. Subtract, obviously, I said. Subtract the 50 we just added over there. And with that, we should be fine. There's like a little offset for some reason. Yeah, I'm kind of a little bit confused about one of the points here. All I did is I swapped the scale value from the 0.5, which was good for animating things, back to 1, as we need the full actual correct value. You could also completely skip this. I just like keep it in here for animations, you know, and this in the gameplay should probably be 1. And I subtracted the 50 back. Though, when we run here now, it's technically working and everything, but you can see how the head wobbles, the arm wobbles with the head. So we need a different kind of calculation. This was more like a testing debug blocker thing. We can just skip this for now, as we need to do this somewhere else. Same goes over here. We can just plug this back in. We keep this as a reminder there and compile this. And we're going to do this in the robot arm actually. And I want here to get actor location, get actor transform. Location, actually location might just be fine. Get actor location. And this here is essentially the bottom of the capsule. So when we're like playing, it is the bottom of the capsule. And then we want to get capsule height, get scale capsule half height. So that we can get the scale of the capsule, so the height of the capsule, and we can break this vector here and subtract from Z. It's getting a little bit convoluted here. Let me make a little bit more space. And now we're essentially taking the height away from the bottom of the capsule. And if we now make vector, vector 3, 1, make vector here. And this is Z, this is still Y, this is still X. And if we now plug this in, we gotta test it. Maybe I switched the subtracts and the wrong way around. I indeed did. Actually, not subtract, we need a add. Add we need, as it should go higher. And there we go. All right. Problem though is now the arm is pointing directly at the top, and we might want this part, this bone, to aim lower. So actually a pretty simple result. We just go back to our robot arm and we just simply subtract a little bit. Doesn't have to be much, doesn't even need to be 50. Let's see, 50 might be a lot. And there we go. This is actually pretty accurate. Okay, well, the thing is now this target tries to go in there, so we kind of have to subtract a little bit in addition here, add a little bit in addition. So we just hit a plus here, I guess, and make another 25. So. All right, now we have to subtract a little bit more now here in the arm. So like, let's say a 75. Okay, and this should now work a hell lot more accurate, as it's going to actually aim at the character. And we don't have the wobble in there from the head. That's pretty cool. Thing is now that we have to subtract also in the animation. So since we already brought over a few variables, you know what, I'm going to make a rewrite here. A bit more clean. We're just going to bring a variable over there for this as well. So let's just make a new variable. I'm just going to copy one here. Subtract height from last bone. And I'm going to set this here. We could just manually type in the 75, or we take in the height here, which is probably more accurate, I guess, and divide it by 2. We could also multiply by 0.5, it comes down to the same thing. And with that, we should kind of get the half of the capsule. All right, just go to your animation blueprint here. Make this a little bit cleaner, maybe. Let's make a reroute here. I really hate it when code looks like, I don't know, super ugly. I don't like this. So you can select the reroutes queue to align them. Delete this one. This is cleaner. Now we want, what did we name it? Subtract height from last bone. Subtract from height last bone, whatever. And we're going to make a variable out of that, as we always do. Promote a variable. And we're going to plug this in. And now we go to our anim graph here in the control rig. Where's our control rig? We're going to make a new variable. I should probably copy the name and paste in the name. Hit the I so we can access it. We're going to grab it. As we know where it should go in here. Now the blueprint will write it, and when we're using it for animation, we do not have anything in here, as we can hit compile. And if you select it, we can set a default value here. Yeah? If the blueprint isn't writing it, then it's just 0 and it's just adding nothing. So we kind of worked around there. Now back to the animation blueprint, as we still have to put it in here. Check this here and get this here and plug it in. Hit compile. We should be good. Let's see if this still works. Yep, still working. If we're jumping, it's interpolating a little bit in, so maybe we should give it a little bit more height. Let's see. Since we set it here like this, it will always adjust itself perfectly. Now, let's say, actually we can maybe go with a 75, let's see. My aim, you can see the point here, right, the red point, is still colliding with the box. This is something I personally have to fix, but I guess it's a good thing to show you as well. I'm actually tracing world static objects, world dynamic objects, and interactables. And the box here is world dynamic. I need an object type which ignores, which is not traced. For that, I'm going to go in, you can see I already opened something here. I'm going to go into project settings and I'm going to look for collisions. You can see I already set up 2 object channels here. I'm going to make a new one and I'm calling this ignore aim trace. And I'm going to just set this to ignore, accept. And if I now go over here to the box, as the box should really not do anything. And we have the ignore aim trace here. And essentially I want to ignore everything. If I ignore everything now, you can see my red dot is not colliding with the box anymore, but also the arm is not tracing anymore. This is very simple because we need an actual overlap. Why do we need an overlap? Because we have the overlap begin actor here. Yeah, we need an overlap with a pawn. A pawn is the character essentially. And if we now do this, there we go, not okay. Ah, yeah, okay. I had to change this from ignore trace to actually overlap, and then it's working. How this works is essentially which type is this current object, which type of collision. It says it's a ignore aim trace object. We want this object, this ignore aim trace object, to collide with pawns. This down here just means should it collide with objects which have the same type, so other ignore aim trace types. But we want it to collide with pawns. So, and now my stuff is working pretty nice. So the last thing we have to do is when we're walking inside here, you can see how quickly it like bam reacts, right? And then we're having the interpolation. We want the interpolation to start slow, and we kind of have a value already for this. This here is essentially, we added this to this control here. Where is it? This one here, I think it was, no? And it was this one here, where one here, right, this one here. Essentially this one here, yeah, we're just like turning it on instantly. So we just need to turn this on slow. And we set this already over here. So instead of setting it right here, we're just simply setting it here with a custom tick. Right. So, and we just need to interpolate it slowly on. So right click, interpolate, or let's just grab out from here, interpolate f_2. And since this is already a variable, this shouldn't be too hard. We are setting this variable obviously over here, and then we're going to use it again. It's the same interpolation as we always did. This is the current, the target is going to be 1, then we need the delta time and the interpolation speed, where we're going to take, let's say, like a 1 for now. Let's see if this works. We can also print this, so let's just use a print here. And we're going to print this out just to see what kind of value we are working with. So let's hit this, and there we go. Yeah. It's going to start, I don't know, actually, does it start at 0? It does start for some reason always at 0. This, I know why. It's still a bit quicker in the beginning. You know what? Let's use a 0.5. 0.5. But it's not like instantly like clipping. It's still a bit quick, but ooh. And this happens because when we leave it, we instantly set it back to 0. I think if we can test this, if we just turn this off here, the interp on is what we currently should skip. Let's see. Right, but it's also not going back. So what we need is to interpolate it back down to 0, and we have to have a smooth transition back to 0. But this would mean this would need to keep ticking. Instead, we can just simply use add timeline. Add timeline will essentially tick until you say it shouldn't be ticking anymore. So play from start, and we want to open this, make a float curve. It's actually pretty easy, and we want to say it should interpolate from 0 to 1. Actually, this should be 0, 0. Make a second keyframe, and this should be 1, 1. And we can hit those signs here, and we can see, can it be, please be 1? So now we have a value which just simply interpolates from 0 to 1 over 1 second. And we can check last keyframe here, meaning it will stop once it hits the last keyframe. We can go back out here. And whenever this triggers now, and this triggers once we ended it, this timeline will just simply run from 0 to 1. We can test this if you want. We can just plug in the update here and come on, update. And this will only trigger once when we're leaving, right? But this timeline will just play. You're going to see, even though this whole thing is just triggering once, now it's like ticking, and it will stop after like 1 second. And this is very helpful to control the ticks. As it's not constantly ticking, it's just doing this tick once and it's done. And we can just simply plug this value here, this 0 to 1. Actually, we need it the other way around, as we want to not get back from 0 to 1. We want it from a value of 1 to a value of 0. All right, it's better. And now this will give us a value from 1, starting with a 1 and then 0. And we want is that this, whatever this here is, that it reaches 0 again. We're going to plug this in here. The problem is now we do not know what it ends with, right? So it could end with like a 0.5, and then it's just randomly 1, and then it goes back to 0. So we kind of have to incorporate the interp on here. Come on, get it. And we're using this as a multiplier. Multiply times this here, and it's going to be itself. Let's just test this, if this actually works. I kind of want to check the value here though. Let me just see what kind of value we're working with here. So we're leaving it. We do not really have a snapping here. All right, it's just that the timeline is a little bit short. Let's open it up, and 1 second is not really a lot of time. Let's use like 3 seconds, or actually 5 seconds. And essentially what's happening is this timeline will over 5 seconds go from 1 to 0, multiplying it with our value and setting it by itself. So essentially whatever it was before, it's slowly multiplying to 0, and if we multiply something with 0, it's going to be 0. And now let's see, we can make a second print here. I just kind of want to watch the value here. So this is where we interpolate it on. All right, and now if we leave it, it's actually going also the way back. Yeah, the thing is, if we enter it within 5 seconds, this timeline is still running. Take a look. Yeah, we're going in, right? And it's slowly interpolating in as it should. We're going out, and this timeline is running. But if we go in again, it's confusing itself. So if we go back in here, this is going back in, right? We want to stop the timeline. Yeah, that should be it. Let's just come get it. So it's going in, it's going out, it's going in. I think we can do this a little bit easier over here. This should probably be plugged in. We can just make a second value, interp on, but we can just call this store. And this is just a value which we need in order to like interpolate it properly back. This is just to store it, because we're going to let this value write as well. And we are going to grab it here, and we're going to just go from this down. And we also have, once the timeline is actually finished and it reached a 0, we have to also set this one to 0. So finished, and this one needs to be 0 then. See how slow it now goes? And if we're going back in, it's going to continue from this value. Shit, what is this? So, but 15 seconds is a bit long this time, so let's just go back to like 3 seconds. Now, this is basically correct as we do it right now. The thing is just, I thought it through, this one here, the control rig interp speed, which I set to like 600 to be relatively quick, should in the beginning also be slow. Otherwise we get like this jittering, this snapping still when we walk in, as one of the lower things is still quick. Actually, I just needed to unplug it apparently, because now we're not setting it anymore, but we want to set it, we just want to interpolate it quick, to a quick position. I'm going to definitely clean this up later. This is super annoying. Essentially we just need to do the same thing as we did here, just with that value. And one should also be fine, I think. We'll see. And I'm going to set this here. And I'm going to watch this value. Okay. This value might need to have a higher target. Let's actually put in like the 600 I had originally. There we go. Yeah, we need a higher value for that. Ouch. And okay. Now we're getting this fast movement because this is still at 600, I think. The other value we see is the other print. Let's turn this off for a second. And I'm guessing we also have to, like we did here, interpolate it down. So I'm going to into the control rig speed, and I'm calling this also store. And we're going to store this here as well. Set storage. And then we essentially can use the same ramp here with the same setup. So simply just a multiply. Just with the store from this one here into this one here. And if it hits 0, the store needs to be 0 as well. Yeah, there we go. Now it's finally doing what I actually want. Fuck, Alter, was ist denn das? Alright, so I found the main problem for it snapping now. Now what we did here essentially is not wrong, though it might be a little bit unnecessary. For now, I'm going to skip this. If I didn't cut it in, you don't have to do this, but just in case, I'm going to skip this for a second. I'm going to skip the ramp here for a second, the timeline I mean. And the rest can just be ignored for a second. And we have to set our values here again. So essentially those two, not the speed, control rig interp speed and interp on. Those two we have to set back up here again. This one was 600 and this one was interp on 1, and we have to turn it off in the end again. 0, 0. Okay. If we take a look here, and we're going to, we can see that at this point here, so basically the transform we put in is directly here. We go back out. it's nicely interpolating and everything. We go back in and it's directly there. Where this comes from is from the animation blueprint. Here we're interpolating very quick. If we interpolate very slow, we can essentially tell how fast it should interpolate to from its last position, more or less. Right, and we will not get this extreme snapping. And in combination with the robot arm, the things we just did, so here play, here interpolate on, and up here stop. We get a very soft interpolation. Problem is that this interpolation in the blueprint is still very slow and constantly is, so we have to increase the interp speed. And since we already have one of those, the control rig interp speed here, we are already interpolating this one here, we should be able to just use this as the interp speed. Let's see. It will get quicker if we turn it off. It should go back. Do we actually interpolate it back? We are in fact interpolating it back. We go in now. There we go. It's just a bit slow, so we kind of just simply have to adjust it now. But how much do we have here? We have 15. 15 is a lot. Let's say 4. So a bit slowly turning on here, to be honest. Oh right, over here I didn't plug this back in, so this needs to be plugged back in here. And then there we go. Alright, and the last thing is that 600 here was just simply a way too high number, meaning you can see that it is increasing essentially so quickly for the other value, for the interpolation inside the UniVP. A 24 should be just fast enough, much enough, and you're going to see now we actually get like a very smooth thing going on here, no matter where we like start with. Okay, I'm going to clean this up and then I'm going to show you like a clean version of that. Alright, I said I would show you the cleaned up version, though let's clean up together because there might be some value in that for you. First of all, this stop timeline here is super ugly that it's going from the top to the bottom. Instead we can just custom event, we call this stop timeline, and we can just plug this into the stop here. Disconnect the other one. Also, a little arrow, we don't want to play it, we want to play from start. Little arrow I had here. The stop timeline needs to be triggered though. When should it be triggered? It should be triggered up here. So we can just grab out from here and stop timeline. Now it will essentially just trigger it. It will shoot it and then it shoots from here. It's just cleaner than dragging it over there. Now here we have a little calculation where we calculate the position of the capsule, where it should aim at, yeah, which we then pass through. We're using this one time up here and one time down here. So what we can do is just select it, right click it, and we can collapse this to a function. So now it's just like a group of things. We can double click on that and we can open this up, right? So then we can also rename a few things. So for example, and up here we can go back to the event graph if we need to, and we can go back in. So first of all, I want to go back out and we call this function. We will find the function to the left, here new function F2, and we call this calc for calculation target pos / subtract height or something, it doesn't really matter. Now we named it. We can go inside here and we can name those two last things here by just clicking on it, and the upper one is going to be target pause for position, and this is subtract from last bone or something. Now we go back out. You can see now it suddenly has like an execute pin, right? But originally we didn't need one. Here in this whole function we don't actually need one. So this is a so-called pure function. You can select it and over here make it pure. And now we have this nicely in here, right? We could probably use it twice. I don't know, I think it's fine the way it is here. We can probably delete the print string as it is working correctly. Print string here as well. It's also good sometimes when you're like cleaning up things just to check again that everything works as you expect it to. Because sometimes when cleaning up things can happen as well. Then we're just going to drag a few things more nicely here. And here we're going to call this interp on. It's kind of a double thing here. And here interp control rig interp speed. It's kind of a double thing. It's a bit weird naming scheme, but it's fine. And down here we can delete a few. Here we're going to make a nice reroute node and drag this a bit down and make another one here. So did I mean to set this to 0? I'm not sure. I didn't mean to set this to 0 apparently. It's alright. You can always select multiple strings and then Q to make this straight. Here we can make a nice reroute node like that. Alright, and compile it. Now let's take a closer look. Here we are checking which we are overlapping with. This corresponds directly to the box, the collision settings where we used custom. We set our ignore aim trace channel. It's a good thing for you anyway, I guess, even though you might not have an aim like I do. But it's good to have this on a separate channel as you don't want it to collide with other things. We set this in the edit project settings under collision. We just simply created a new one and we made sure it's an overlap default response. And we made sure when we set this to custom that we are overlapping with the pawn, which is the character. We want to know when this box is overlapping with the character as we're walking into the box to trigger things. Then we're setting a timer. I don't think this is quite the correct order, as the custom event only should start ticking after we did this here. So instead of doing it here, it should be in the end. We didn't see a clear arrow because of this, but it is just more logical to trigger this afterwards. Now you can see we are dragging this here from the event all the way to the top. I don't like this like spaghetti thing, so we can just get a create event. All right, and we can plug this in here, right? And then we will have like, can select one. And which one do we want? We want to trigger the custom tick. So custom tick, yeah. And that way we can do the same thing. We can tell this node to use this event here, just that we don't need to drag it all the way over there. We can copy this as we need it down here as well. Plug it in. And custom tick. All right, I'm just checking if everything still works. Seems to be fine. Let's check that nothing is ticking anymore here. Timeline just ticked a little bit, but this is working. Now the last thing is that here, this is super ugly. You know what we're going to do? We are going to disconnect this here, right click, and promote to variable. And we call this overlapping character, okay? And now we can just set this here, right? And the idea now is that we store whichever character we're overlapping with, and we can grab this here, plug this in here, and we can also grab it here again. Actually, we can grab the whole function here again, set it down here, and plug it right in here. Delete this. So, and even more clean. Let's check things. Still seems to work pretty nicely. And for your understanding, I mean, I can read this a little bit of code without a problem, but if you want, we can just write a few notes here for you. Send one tick when something overlaps. Yeah. What are those other actors? Those other actors are mainly, first of all, checked in here in the box in the collision settings. This is where we set it up. We made it ignore aim trace, which has a default result of overlap, and then we set custom collisions. We say it should ignore everything beside character pawns or pawns. Then we cast it, and this is just check if it is actually this blueprint. Yeah, with the cast you can make sure that the rest only triggers when it's actually the thing we're casting to. So cast to default enemy, if only if it's this blueprint. We're setting it in a variable. I don't think we need a frame for that. We're just storing whatever we're overlapping with, and then we're setting a variable which we are setting a stop timeline event. This should probably be, yes, this is fine. And here we can create custom tick event. Yeah. So when we're overlapping with only our character, we're setting the variables, and we're creating a custom tick, which is this one here. Then we're interpolating our values, which we are later grabbing. We are setting our target, and when we're leaving the trigger box, we again target our custom tick and make it stop. 0, no looping. And then we are playing our timeline, and the timeline when plays interpolates our values back to 0, and should it finish, we're just double checking that those values are 0. Should we enter while the timeline is playing, we are sending a stop timeline event and make sure the timeline stops so it doesn't run the timeline while we're actually inside it. And with that, this looks much cleaner. So this does it for this video. A lot of thanks again to my Patreons, which is still just Shard. Again, if you feel like supporting me and my videos, link in the description. If you want to learn more, I also have a link in the description to my courses. We have some Blender courses about anime. We have a few Unreal courses about shading. If you're interested, just take a look. It's not going to hurt you if you just check it out. And I see you in the next video.